All right, today we're going to dive into something I find absolutely fascinating. How does a massive, heavily regulated organization like a bank build its own private AI? We're talking about a journey into the heart of data, security, and some really, really clever engineering. So let's just get the obvious question out of the way first. Why would a bank go through all the trouble and, let's be honest, the expense of building something custom when amazing tools like ChatGPT are right there? Well, it turns out when you're dealing with other people's money, the easy way is almost never the right way. It really boils down to three huge, flashing red lights that are complete non-starters for any financial institution. First up, data leaks. A bank simply cannot, under any circumstances, send your private financial data to some third-party server. That's a massive security and privacy nightmare. Second, you've got hallucinations. This is when the AI just makes stuff up, but says it with total confidence. In the world of finance, a wrong answer isn't just an oopsie, it's a potential compliance disaster. And finally, there's the stale knowledge problem. Public AIs, they were trained on the internet from a while ago. They have no idea what the bank's internal policies are today, what the market did 5 minutes ago, or anything about your specific account. Okay, so how do you fix that knowledge gap? Well, you start by giving the AI a library card. But not just any library card, one that gives it access to the bank's private internal library. Think of the AI as this brilliant new intern. It's incredibly smart, it can reason through complex problems, but on day one, it has zero access to any of the confidential company files. We need a secure way to hand it exactly the right documents for the job, and only those documents. And this is where this really clever architecture comes into play. It's called Retrieval Augmented Generation, or just RAG for short. Now, the big idea behind RAG is brilliant in its simplicity. You separate the AI's ability to think from its memory. The large language model, that's the brain, but the knowledge, the actual data, that's kept separate, secure in the bank's own systems. Just by doing that, you suddenly make the entire system way easier to update, to audit, and to keep secure. So here's how that RAG process actually works. It's the simple but really powerful four-step dance. First, a user asks a question, something like, "What's our policy on?" Then, the system instantly retrieves the most relevant documents from its private database. Next, and this is the key part, it augments the original question, basically stapling that retrieved info to it as context. And finally, it hands that whole package to the AI and says, "Generate an answer based only on the information I just gave you." The AI isn't using its old, stale internet knowledge anymore. It's reasoning in real time with the bank's own trusted data. So this RAG system is a massive leap forward, right? It totally solves the stale knowledge problem and the data leak problem. But as engineers started to push it, they found that when you get into more complex, real-world questions, this basic library card approach starts to, well, it starts to fall apart. And here's where things get really interesting. You ask a simple question like, "What's our credit card late fee policy?" RAG can handle that all day long. It'll just go find the one policy document and give you the answer. But what happens when you ask something more complex, something that connects multiple ideas? Like, which risk policies apply to new tech sector clients who are in California? Suddenly, those key concepts, risk policies, tech sector, California, they might live in totally different documents. And that gets to the core of the problem. A simple RAG system is amazing at matching the meaning of your question to a chunk of text, but it doesn't understand the hidden relationships between all the different concepts. It has no idea that tech sector is a specific type of client that links to a specific set of risk documents, or that California has its own unique regulatory rules that apply. It's missing a map of how all these ideas connect. So the solution is to give the AI a second brain, a much more structured brain, one that's built from the ground up to understand relationships. This is where we see the next evolution of the system, and it's called GraphRag. So, let's break this down. That first library we talked about in the basic RAG system, that's actually what's called a vector database, and it's what gives the system that smart semantic search power. Instead of just looking for keywords, it actually understands the meaning behind your words. It's how a search for, say, charges for closing a loan early can find a document that only mentions prepayment penalties. It's a library of concepts. But now we add the next layer, the graph database. And you can think of this as our relationship map. Instead of just storing raw text, it stores concepts as nodes, things like California or policy ABC, and the relationships between them as edges, things like is located in or applies to. This structure lets the AI literally follow a logical path from one idea to the next, uncovering answers that a simple search would completely miss. So GraphRag is the fusion of these two incredible tools. When that complex query comes in about tech clients in California, the system uses both databases at once. The vector database finds all the documents that might be relevant based on meaning. But then, the graph database explores the relationships between those entities, tech sector and California, to build a much smarter, much more accurate context before it ever asks the AI to write a single word. Okay, so having this amazing technology is one thing, but for a bank, where and how you house it is every bit as important. You can't just spin this up on a public cloud server. Nope. This thing needs to live inside its own secure digital fortress, completely and totally under the bank's control. And inside this fortress, the security is just layered. First, everything is on-premise. That means the hardware, the data, the AI models, it all physically lives inside the bank's own data centers. It never touches the public internet. Then, access is locked down tight. Employees can only query data they are explicitly authorized to see. You have automated systems constantly working to mask sensitive personal info. And maybe most importantly, every single question and every single answer is logged in a full audit trail. This isn't just for security, it's for the regulators. It creates a transparent, provable record of exactly how the AI came to every single one of its conclusions. I mean, when you put it side by side like this, the difference is stark. It's night and day. With a public API, your data is going to a third party, you're stuck with public knowledge, the AI's reasoning is a black box, and you're completely dependent on an outside vendor. With a private system, your data never leaves your walls. The knowledge is your own proprietary data, every single action is auditable, and you have complete control. For an institution like a bank, there's really only one choice here. So, what's the big picture here? What does all this add up to? Well, this secure private AI system, it's a lot more than just a clever solution for one bank. It's actually a blueprint for a fundamental shift in how every large organization is going to use artificial intelligence from now on. What we just walked through is pretty much the emerging gold standard for enterprise AI. Think about it. Any organization that deals with sensitive information, we're talking hospitals, law firms, government agencies, they're all going to need their own version of this AI fortress. This is all about creating a private, trusted intelligence that can finally and safely unlock the incredible power hidden inside an organization's most valuable asset, its own data. And that leaves us with a really fascinating thought to end on. This technology is shifting from being this centralized tool built by just a few tech giants to becoming a distributed, private capability. So what happens next? What does the world look like when every major company, every hospital, every institution has its own secure, trusted, and incredibly intelligent AI brain? That's something to think about. Thanks for tuning in.